Button?
So you want me to share screen and talk?
Yes, you can
All
start
right.
now.
Okay. Just a second here. All right. This talk has two titles. Just a moment. I'll set it so that it works there. You should be able to see that easily.
Yes.
That clear? I want to check something. Oh, just a moment. Yeah, something about my pointer. Um, I don't seem to have the ability to move a pointer in this forum. Let me try one more time. There's a pointer. You can see it,
Or
right?
if you
Mm.
do the slideshow mode, you will have to click a button to turn the page.
Yeah, yeah.
You will
But I'm
have.
just adjusting something. But I don't think you get to see my pointer. In this mode, you
We
do
can
see
see
the
it.
point. Yeah, but
Yeah, you have a
I'll
pointer
put it in
now.
the slideshow mode, and I may go back if I want to point at something. So, um,
Move the
so that
mouse.
so
Move the
there we
mouse.
are. You can see this, right?
But no pointer.
Yeah. We can't see your mouse.
We can see the image, but not pointer.
You should be able to see my screen with a title.
Yeah, it's the
And
slideshow.
I'm changing screens
Yeah,
in the okay,
yeah.
that's fine. If I want a pointer, I'll go to the other mode. So the general title of this talk is Reflexivity, Recursion, and Self-Reference, but the specific title that we had wanted to talk about here was advertised at least as Knowledge and Belief in Mathematics, Logic, and Cybernetics, and in relation to a paper I'd written called Cybernetics of Language from Naming to Naming the Self. And the contents of that are going to come out from the general discussion. So I'm going to start back at the level of the general discussion. And so I like to start with Heinz's well-known sentence, um, I am the observed link, or I am the observed relation between myself and observing myself. Um, this is a circular statement, and its meaning um, emerges in relation to the person who participates with that statement. Um, it can it is of interest to us in that regard that in attempting to just to write down what self or self-reference is, he actually asks you to participate in his language, and the language asks you to participate with it. And it can be thought about in many different ways. I'm not going to go into the many different ways here, but it is of interest to compare it with John Wheeler's statement about physics, which was that no phenomenon is a real phenomenon until it is an observed phenomenon. And then he indicated a self-referring or a self-observing universe in the form of the letter U with an I on it, observing itself back to the thinner part of the U, which could be regarded as the beginning of the Big Bang. And there are a lot of thoughts that can occur around this, but we'll go on. Von Forster's sentence points to the recursive and self-pointing nature of the eye of an observer. Wheeler's sentence points to the universe as a participatory universe, where the real emerges in the participation of the observers with their own actions. And the essence of observation, at least in the Wheeler sense, but perhaps in the cybernetic sense as well, is a projection from possibility to actuality. We can continue with the eye. Von Forster's eye is an example of an eigenform, a fixed point of the operations of its context, and possibly created by that context. So, for example, I say, I am the one who says I. And if we look at the formal structure of that, we understand immediately that the I on the left, of course, is not the same as the I on the right, um, but they're related. And if we started to diagram it, we might write, I am equal to the one who says I, and then the equality becomes a process. And I am equal to the one who says I. Um, you could have put something else for the I in the right-hand side. There's an operation there, the one who says. And I am the one who says I. There's an operation on the I that leaves the I fixed. Any person constitutes a solution to this equation. And then you see another aspect of how there's more than one I in the formula. I say this, but you can say this, and anyone can say this. Any given person performing it constitutes a solution to the equation. Each and every speaker is an I. So the problem we're thinking about is the relationship of observation with self-reference, reflexivity, and eigenform in this sense. In an observing system, what's observed is not distinct from the system itself, nor can one make a complete separation between the observer and the observed. And this is true independent of most of the theories that we have. I might speak in a purely cognitive way, and you might speak in terms of the structure of how the brain works. But these observations seem to go across the board in this transdisciplinary way. The observer and the observed stand together in a coalescence of perception. From the stance of the observing system, all objects are not local, depending upon the presence of the system as a whole. It's within that paradigm that these models begin to live and act and enter into conversation with us. Now, I happen to like to use the Spencer-Brown mark, so we might introduce it. It's just a mark, but it's a mark you're looking at, and it's a mark that you're seeing as you're invited to see as making a distinction between its inside and its outside, where the inside is what's underneath that upper corner there in the concave part of it, and um, and of course, if you wandered away from the upper corner, you could escape and get into the outside. So it doesn't insist on a distinction, but it suggests a distinction. And you could make the distinction more precise by saying, well, I really meant a box. And of course, this is one of those things. Once you've understood that you could think of it as a box, it's very difficult to think of it as anything else, even when the box is not there. So you, as an observer, are coalesced with the mark. You are making it into a distinction by interpreting it the way you do. Now, we said belief, and I wanted to bring belief into the talk a little and then see it come in more. And it's not exactly that I believe that this makes a distinction, so much as I have been suggested into seeing that it makes a distinction. But then it becomes part of my perceptual system that I see it as making a distinction. And things that are in our perceptual systems are often shifting into beliefs, and we have to think about that. Another example of what the observer does is this good illusion here, because the observer sees things that aren't there by projecting them out into the scene that it is observing. Here, what you see that is not there is a white triangle um, between the three Pac-Men. And you might look carefully and understand that the triangle isn't there. There are no boundaries to that triangle, just the edges of the mouths of the Pac-Men. But when we look at it, we seem to see quite clearly the whole triangle and its boundaries, suggested by what is in the picture. Or the Penrose triangle, which is a non-standard object in our observation. Everyone looks at the Penrose triangle and says, "Oh, I see an object there." Um, it doesn't even seem paradoxical to me, just kind of strange. But if I look very carefully at it, if I do a little investigation, like put something over one of its corners, then I realized that it really couldn't have been built in three-dimensional space the way it's depicted, because everything other than what's in the gray area is a realistic drawing of um, something made of wood, you might say, which is not meeting itself at that corner that's obscured. And it wouldn't if it were done realistically. And yet, there it is. And so your observer seems capable of making an imaginary object, and it seems stable to you, at least to me. It seems stable even though it can't be made. But what do you mean when you say it can't be made? Now you're taking another belief, the belief that this is a realistic picture. And in this case, your belief that it's a realistic picture takes hold and shows you that it is realistic up to what might not be seen under the gray area. And then you understand that this is not a realistic picture, but somehow you shift back into allowing it to be an object anyway. It's mysterious. Um, this, of course, is thematic about things building themselves, but not really building themselves. Actually, it's just a drawing that somebody made. Now, I want to talk about objects a bit, and so I like to use knots as an example. Knots are man-made objects. They sometimes occur in nature. This is certainly a man-made object, this weave of Leonardo da Vinci. It's not a real weave, but of course, he is building or standing on the whole thousands of years of tradition of weaves and making an artistic weave here, um, and quite intricately. I might look at a weave, make it out of rope even, like this one, made out of computer rope, and and then is it really woven, or what kind of an object is this? And I'm thinking of this as a flexible object, which is an object worth thinking about because we have flexible objects in the world, in our worlds, and flexible objects are quite different from the usual object that one thinks about or one has been inculcated to think about since the beginnings of geometry. They're rigid objects, and we tend to make rigid objects like your car. You don't want to be able to pick up your car and bend it like a pretzel. But you can bend this like a pretzel, and you can move it around without cutting it or pushing it through itself. And then you have a puzzle. Maybe it really could be undone. And in fact, it can be undone, but we're not used to being able to visualize that. And so this object has properties, direct properties in its flexibility that are beyond our direct perception. In order to observe the fact that this is unknotted, you have to go into a process of pushing it around. And having going into that process, if it was made of rope, you could have done this with your hands, and it would come apart, and become unknotted. So, or you could have taken something like that and folded it on itself and made it into the weave that you see, but this weave actually isn't knotted. And that's a property of this object, which is not in your direct perception, but nevertheless you would regard it as a property of the object. So that this is, of course, a simple moral about objects in the world, that objects in the world have histories and they also have possibilities. And in order to understand them, we can't just be a one-eyed observer of the object. We have to know much more. In the case of flexible objects, we have to be able to think of putting them in the process of flexing. And the knot is another good thing about the knot is that it's a pattern that is on some substrate. So the knot could be tied in fuzzy rope, or it could be tied in crosshatched rope, but the knot as a pattern becomes an actuality that is independent to some degree of its substrate. And other beings than us are willing to turn loops or even knots into objects and play with them. Uh, so when we start talking about objects and patterns that form objects, we are playing back and forth in the in the realm of what is imaginary and what is real. Certainly that could be a theme for what I just said over the last 10 minutes, the theme of the imaginary and the real. And 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 then you get to belief again, because do you believe it's real is a natural question. But but most of the things that we were looking at were drawings, and they aren't real, but they could represent something real. And some of the things that we were looking at can't be made real, at least not rectilinearly, like the Penrose triangle. So there is the question of reality and belief, and the relationship between the imaginary and the real. But in back of that, there is always the question of authenticity, in the sense of, do I know how I made it? Is it authentic for me? In what sense is it authentic? The Penrose triangle is authentic, but it's not real. And I want to talk about referential domains, and I'm going to talk about the notion of a reflexive domain. So, a reflexive domain, this goes back all the way to the von Forster sentence. A reflexive domain is a place where every object is a transformation, and every transformation corresponds uniquely to an object. So that's an abstract way of describing our situation as participants in our worlds. We are each entities in the world, or beings in that world, and we also, in being who we are transformations of that world. So one can take that as a principle and see where you can go. Um, and that means that one can play the mathematical game with it if one wants to. To play the mathematical game, one says, I'll let X be an object. It could be a person, it could be a corporation, it could be the AI underneath this computer program, it could be anything. It could be just a hand, it could be anything. But it can act on itself and it can produce a new object. So now we're in this compositional world where objects proliferate enormously, because if anything interacts with anything, it becomes a new kind of thing. Um, and and so one finds that eigenforms are immediately happening all over the place if you have a reflexive domain, because of the following long ago old trick, going all the way back to Russell perhaps, that I could define an operation on an X by defining it to be some other entity operates on X operating on itself. I'm saying this abstractly, but we'll get a more concrete version in a moment. But as soon as that happens, then the new entity G could interact with itself, and then it is a fixed point for the T. So that any T has a fixed point. It's an abstract argument, and it's very close to paradox. It's very close to Russell's paradox, among other things. So I'll skip this slide. Um, When we get those fixed points, we have forms that are re-entering their own indicational space, just like I am the one who says I, and the second I re-enters the indicational space of the first I. And so you can think about recursive forms, and this makes sense in terms of process, where the form re-enters its own indicational space, and it is through that that forms are evolving, which you couldn't have thought of otherwise. That is to say, here I have a 90-degree triangle, a 90-degree angle, and I take the notion that every edge, every straight edge, is going to be replaced by a 90-degree angle. Whenever you see a straight edge, it's going to be replaced by a 90-degree angle. A recursion, a very simple recursion. Um, that is going to make a form which looks like two copies of itself, one up here and one down here at 90 degrees to it. But you can't tell without doing it what you're going to get, any more than you could tell whether that knot was unknotted without getting it in your hands and moving it. So in this case, the drawing program is doing this again and again. This edge here became a 90-degree bend, and this edge here became a 90-degree bend, and every edge becomes a 90-degree bend, and we do this over and over and over again, and eventually it begins to look like that snail kind of entity, and you can see that that infinite snail entity is two of them, one curling up like this and the other one curling up like this, and they're superimposed on one another at 90 degrees to one another. They're overlapping. Um, and you can't predict it. You can take the simplest of rules and apply it to itself again and again and again. You get the simplicity of this form is equal to two copies of itself at 90 degrees to each other. But exactly how it's going to look is beyond your ken unless you actually explored it. Similarly, a simpler one that everyone knows, where each edge is replaced by a triangle in the middle of that edge, and the edge is broken up into four like that, and you do it over and over again and get the famous Koch fractal. And the simplest example of this is just re-entering something into itself infinitely and getting a nest of boxes, getting just the pure form of re-entering into itself. Now we get to naming, and near the end of the talk also, if you're wondering. So here I've given it abstractly. But let me say what I have in mind. I have in mind the form of introduction. You're introduced to me, or I'm introduced to you. Perhaps I'm introduced to Jason. And so someone says, "This is Jason." And I say, "Aha, Jason, how do you do?" And I shake his hand. And then if I'm paying attention, then Jason name is associated with Jason's face and body and person in the world. And the next time I see Jason, don't just see that person, I see that person and the name is over there, just like the uh, triangle that I can't really see, but I do see is over there in that triangle illusion. Jason's name is over there with him in my perception. And I have shifted from Lou is introduced to, I'm sorry, Jason points to this person to a version of Jason's name is now pointing to Jason, but he has his name associated with him. Um, and of course, we do this all the time. And if I meet Jason and I can't remember his name, it feels a little funny because it's as though I somehow went back this way. And I know I should know his name, but it isn't there. And so a lot of the time we've stabilized this and we meet friends and we know their names, hopefully. So I call that the indicative shift. The name points to the object, but that isn't enough. The being who is going to learn that name, indicated by sharp, becomes welded with the name. That's me knowing Jason's name, and the name in the perception of that being becomes welded with the person seen uh, like that. So if Alice is introduced to Bob, oh no, I'm sorry. If I'm introduced to Alice and I'm told that this is Alice over here, bad cartoon, and that's supposed to be me, then me understanding the name of Alice is now pointing over to Alice with her name. That's the shift. Um, and suppose that you have your own name. Then you introduce yourself to yourself. My name is Lou, but suppose my name was Alvin. Then Alvin points to my being for me. Uh, but that's happening in my being. This is my being. And in my being with Alvin, it's pointing to in my being with Alvin. And now we have the self-reference. Now, the in my being is turned into an abstract operator called shift, which is a little strange to me. And I think I need to think about it further. If I'm describing self-reference, I think of self, and I think of my being as holding your name. And within the context of that, I see you as Jason. Um, but if I want to write it down in an abstract way, then I talk about a shifting operator. And the point is that it is the being, your being, that's doing that shifting. Um, but if we made a mathematics out of it, we lost the being, and we always seem to. It's the way it is. So we have the indicative shift. And if, on the other hand, M was pointing to the operation of shifting, M is pointing to the being, then the shift applied to M refers to the shift applied to M, and you have self-reference. So, so this is what was happening in that paper that was being referred to at the beginning of this talk. And of course, you can get self-reference by insertion of just the right kind, like this sentence has 33 letters. And you can get this kind of shifted self-reference in intellectual situations like the Gödel situation. In the Gödel situation, you have a number, which is the reference number for the statement, something is not provable. And if you write that G is the reference number of a predecessor statement, not provable, the shift of something, then you shift it and you find that the shifted name is now pointing to that very statement that asserts the unprovability of itself. You can get something to assert the unprovability of itself by doing this trick. That's Gödel's trick. Gödel's trick is an example or a special case or a slightly more complicated way of doing the indicative shift. He gets something to talk about its own name. And he gets something to tell that the statement with that name is unprovable. And this results in the Gödel incompleteness theorem. It results in the fact that this system, if it's assumed to be consistent, and now we're getting near to belief again, we have some system of deduction, and we assume that it's consistent. Well, if it's consistent, then it couldn't prove this little statement over here, because if it could, it would prove that it couldn't, and it would be inconsistent. And then you get into the following, which I'm going to take your time with for a little bit, and then we'll quit. But this is where we get to belief in a deeper way. You'll see what I mean. I'm doing the Gödel argument all over again here. M is the mathematician, and he's arguing about T, the formal system. And M assumes that T is consistent and that T can do arithmetic. And that means that M can arrange the Gödel numbering, just like we saw, and can articulate a sentence G. That's a sentence that asserts its own unprovability. And then M argues that if T can prove G, then T will prove a statement that asserts that G can't be proved and hence could deduce the negation, and that would make T inconsistent. Since M has assumed that T is consistent, that means that M can prove that T will not produce a proof. And that means that M has proved G. So M has proved a theorem that T cannot prove. That's the outline of the famous Gödelian incompleteness theorem. But now let's think about this. I want to tell a little story. We consulted a certain oracle who's spoken to a demon. And this oracle tells us that, in fact, T is identical with the mathematical workings of ourselves. But then the above shows that the mathematician is inconsistent, having proved a theorem that can't be proved by the mathematician. M had assumed that T was consistent, but it turns out that T was inconsistent. What happened? But this isn't how we proceed. We assume that our reasoning can be made consistent. And now the question is that a belief in the theme of belief? Is the assumption that we make all the time that our reasoning, our way of observing the world, can be made consistent? We assume it in order to do science or mathematical science. And so if we assume that we are consistent, can be made consistent, then the only conclusion is that the oracle misinterpreted the demon and T is not identical with M, and M is not a Turing machine after all. And so this is how you can argue on the basis of your belief that you can reason correctly, that you're not a Turing machine. If I can be consistent, if I can be a consistent reasoner, then I couldn't be a Turing machine. I couldn't be a formal system by the Gödelian argument. But there's a belief in there. There's a belief that I can be a consistent reasoner. And so we are now confronting that question of whether we can be consistent reasoners. At this point, the question of belief occurs. Do you believe in the consistency of your own thought? Do you believe in the consistency of the systems of thought that you wish to trust? Do you believe in belief? Do you believe in yourself? What does it mean to believe in the self in the light of this kind of form of self-reference? So I've wandered you through a lot of different thoughts, but in the end, the question becomes, what about our own integrity in relation to our ability to reason? And we're faced with this all the time. In the political realm, we're faced with this in the realm of dealing with technologies like the AI. We're faced with this all the time. And I think it's not, is it a matter of belief or is it a matter of understanding who we really are, whatever that might mean, to have that trust? We need that trust. So this is a complicated issue, and I don't think that it has a single answer. Um, I would end with a little cross between the Heart Sutra and Laws of Form, and read this to you and stop. In the light of no thing, we take the form of distinction for the form. Emptiness is not other than form. In emptiness, there is no form, no discrimination, no distinction, no absence of distinction. The form we take to exist arises in framing nothing. I see that. Sorry, I wanted my last slide. And so we will silence this slideshow.